Okay, I just went ahead and started scanning the text here. I don't know that I necessarily need to read every little bit. Mongo has some key features that helped it become so popular. As we mentioned before, the goal was to create a new breed between traditional database features and the high performance of NoSQL stores. As a result, most of its key features were created to evolve beyond the limitations of other NoSQL solutions, while integrating some of the abilities of relational databases. In this section, you'll learn why MongoDB can become your preferred database when approaching modern web application developments. Okay, the BSON format is what's new to me. One of the greatest features of MongoDB is its JSON-like storage format named BSON, standing for binary JSON. The BSON format is a binary encoded serialization of JSON-like documents and is designed to be more efficient in size and speed, allowing Mongo's DB high read-write throughput. Like JSON, BSON documents are a simple data structure representation of objects and arrays in a key value format. A document consists of a list of elements, each with a stringed typed field name and a typed field name. These documents support all of the JSON specific data types along with other data types such as the date type. Another big advantage of the BSON format is the use of the ID field as the primary key. The ID field will usually be a unique identifier type named object ID that is either generated by the application driver or by the MongoD service. In the event the driver fails to provide an ID field with a unique object ID, the MongoD service will add it automatically. Okay, and this is where I kind of stopped and decided it was time to start recording when I got to this. A 4-bit value representing the seconds since Unix epoch. So the first 4 bits, I don't know, we'll say digits for now, I don't know exactly. First 4 bits value representing the seconds. So, okay. Well, you might want to look up Unix epoch, but it's a time value. A 3-bit machine, let's see, 4, so yeah, 7, 8, 9, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So it's exactly 2. So 1 bit, 2 bit, 3 bit, 4 bit. So that represents the seconds, the number of seconds since the beginning of time, since the Unimatrix 1 was turned on, since the whatever time they chose to represent the beginning of time for the internet. That's how many seconds have passed. And then the next 3 bytes, which is going to be 6, 1, 2, 3, 4. There's a 6-bit, there's a 3-bit machine identifier. So that's probably like based on your IP address. That's like your serial number to the node you're on. And then a 2-bit process ID. So you're running this thread. You're probably always running several threads at once. But however many processes you're running, like say I'm running a process for my mouse, a process for my render, a process for time, all these local processes in the computer. But being single threaded, they would all have their own unique process ID, like there would be one. So then after that, just say so they don't run into a Y2K issue once you get into quantum computers and maybe you've got a thread that can do 2 things at once, then it adds another random number. So the odds of the cat being dead in both threads at the same time is pretty slim. But anyways, that's your ID in this BSON object, because in a database, if you're organizing your data by tables, you want a unique key value pair. You want you want to know that the precise table you're looking for, especially if you're going to use that as a reference point in another table to get back to it. So these are all just in one huge column. They're all in the same BSON. Like there's a huge BSON list, and these are all just the nodes that pop off of that. So this unique ID is this blog with these comments. So that's your BSON object. The BSON format enables MongoDB to internally index and map document properties and even nested documents, allowing it to scan the collection efficiently and, more importantly, to match objects to complex query expressions. MongoDB Ad Hoc Queries, one of the other MongoDB design goals, was to expand the abilities of ordinary key value stores. The main issue of common value stores is their limited query capabilities, which usually means your data is only queryable using the key field, and more complex queries are mostly predefined. To solve this issue, MongoDB drew its inspiration from the relational database dynamic query language. Supporting ad hoc queries means that the database will respond to dynamically structured queries out of the box without the need to predefine each query. It is able to do this by indexing BSON documents and using a unique query language. Let's have a look at the following SQL statement example. Select all from post where title like Mongo. So when I was writing PHP and you were making an SQL CRUD app, this would be your query to the database. Select all from this is the name of your table, where your key in the table contains Mongo. So this is again kind of like all. It could have anything in front of it, anything after it, as long as it matches Mongo. So it could be like just start there, or it could have a Mongo DB, and if that was in this field of this table of this database, or anything in this database. This simple statement is asking the database for all the post records with the title containing the word Mongo. For all the post records with the title containing the word Mongo. Replicating this query in MongoDB would look like as follows. Database post find title Mongo. Okay. That's the way you would write it as a query, so that makes sense. DB post find. It's probably defining DB as an object, and it has all these listed as functions, and you're feeding that as your variable. It's your variable, like dude said, equal to that. So my only question is if it looks like it confines it to a word here. I was thinking it would take anything before and after, but I think with those bars, I think that's a little different. Maybe not. It looks like it wants it isolated as a single word there. I think here it would have stuff, it would let stuff touch up against it. I don't know why I think that. My gut instinct tells me that's right, but that could be an intuition and not a fact. Running this command in the MongoDB shell will return all the post whose title field contains the word Mongo. It still feels like it's isolated word Mongo. You'll learn more about the MongoDB query language later in this chapter, but for now it is important to remember that it is almost as queryable as your traditional. I wonder what the almost excludes. As your traditional relational database. The MongoDB query language is great, but it raises the question of how efficiently these queries run when the database gets larger. Like relational databases, MongoDB solves this issue using a mechanism called indexing. Okay, I remember indexing. You could speed up your database queries by indexing. It would have like like you don't have to go read everything, just read the index and see if what you're looking for is even going to be in there first. If you're going to the library, you'd start with the Dewey Decimal Card catalog. Instead, you would start with the list of what's. You'd flip through your cards and be like, oh, that looks like a good book to go look up, and it looks like it happens to be in MongoDB indexing. Indexes are unique data structures that enable the database engine to efficiently resolve queries. When a query is sent to the database, it will have to scan through the entire collection of documents to find those that match the query statement. This way, the database engine processes a large amount of unnecessary data, resulting in poor performance. To speed up the scan, the database engine can use a predefined index which maps document fields and can tell the engine which documents are compatible with this query statement. To understand how indexes work, let's say we want to retrieve all the posts that have more than 10 comments. In this instance, our document is defined as follows. Comments count 12. That spread document, that spread there could mean there's like several in here. The spread operator. I don't think it's an operator there. I think it's just a representation. Might be a placeholder. It could be a spread operator. Other than that, I feel like I recognize that, and that's a BSON object. So a MongoDB query that requests documents with more than 10 comments would look as follows. So I think this is how it's written, yeah. So I think this is the index part. Instead of counting the comments every time you send it a query, it just already has a reference to it in the index. Comment count. Find where comment count. Not sure what the GT get, but the cache sign looks like a variable. Or comment count. It's greater than. For some reason, the arrow sign you'd normally use for greater than, less than, would probably trigger an underlying language. It would probably be like a key in HTML that you don't want to trigger or something. So they've got to like do an interpretation. Be like, well, this represents that, so that's a greater than 10. That's what that is. Okay, so to execute this query, MongoDB would have to go through all the posts, and you know what? That's probably, I've been out of PHP. No, it's not PHP. I don't know. I'm not sure what this part is right here. It is greater than 10, but it's not important right now. To execute this query, MongoDB would have to go through all the posts and check whether the post has a comment. Did I even start the timer? No. Piggy, why are you showing up late to work? You got 11 minutes left. Okay. To execute this query, MongoDB would have to go through all the posts and check whether the post head has a comment count property larger than 10. However, if the comment count index was defined, then MongoDB would only have to check which documents have a comment count property larger than 10 before retrieving these documents. The following diagram illustrates how a comment count index would work. So it's pulling them. almost pulling them in order. And the next one after that, okay. Those are all the ones that are, so these are under 10. Using the comments count index to retrieve documents with more than 10 documents. Okay. That was almost too simple to want to read, but I get it. Mongodb replica set to provide data redundancy and improve availability. Mongodb uses an architecture called a replica set. Replication of databases help to protect your data to recover from hardware failure and increase read capacity. A replica set is a set of MongoDB services that host the same data set. One service is used as the primary and the other services that are used are called secondaries. All of the set instances support read operations, but only the primary instance is in charge of write operations. I think I get that. When a write operation occurs, the primary will inform the secondaries about the change and make sure they've applied them to their datasets. Replication. The following diagram illustrates a common replica set. Read write. It feels like it's missing something. Replication, primary, read write. Maybe not. The workflow of a replica set with one primary and two secondaries. Another robust feature of the MongoDB replica set is its automatic failover. When one of the set members can't reach the primary instance for more than 10 seconds, the replica set will automatically elect and promote a secondary instance of the new primary. When the old primary comes back online, it will rejoin the replica set as a secondary instance. Another feature of the replica set is the ability to add arbiter nodes. Arbiters do not maintain any data. Their main purpose is to maintain a quorum in the replica set. I gotta look up the word quorum now. Come on, Q. What kind of mystery are you running here? This means they participate in the process of electing a new primary. In short, arbiters help provide consistency within the replica set with a cheaper resource cost than regular data nodes. The following diagram illustrates a common replica set with an arbiter. Heartbeat. The workflow of a replica set with a primary, a secondary, and an arbiter. Replication is a very robust feature of MongoDB that is derived directly from its platform origin. It is one of the main features that makes MongoDB production ready. However, it is not the only one. To learn more about MongoDB replica set, visit documentations at mongodatabase.org. Organization manual replication. It's really not. It's probably automated replication. Alright, I'm not gonna look that up now. We got about 6 minutes, 5.5. We're gonna finish reading what we got here. Can we make that in 5 minutes? Filming my reading may actually be. It wasn't to speed read. It was to focus on comprehension. I can actually loop these back and kind of read to myself even while I'm sleeping and get some osmosis. Sometimes I'll do something and I gotta see myself do it again to let it sink in. I can also put them on loop for the channel. I have to go out to work. I can loop episodes and then broadcast the loops. Anyways, but that being said, this was a pretty long page. Well, a lot of it wasn't that long. It took me 20 minutes to read down to there. But more importantly, I feel like I'm comprehending most of this. Alright, so we can finish this in 5 minutes. Sharding. I've heard of sharding before. It happens like with the holocron, right? Scaling is a common problem with a growing web application. The various approaches to solve this issue can be divided into two groups: vertical scaling and horizontal scaling. The difference between the two are illustrated in the following diagram. Now, we had vertical and horizontal app structure in the previous chapter. So now we're doing horizontal and vertical databases, I guess. So we're thinking in extra dimensions. Figure out what's going on here. Vertical scaling is more RAM. Oh, okay. I gotta get this. Machine 1, machine 2. More RAM, more CPUs. Not entirely. I mean, isn't more RAM? Isn't a RAM a machine? More CPUs is more machines. More hard drives is more. I don't know. It's just all on the same motherboard. Different threads. Vertical scaling with a single machine versus horizontal scaling with multiple machines. What makes them different machines, though? Because the RAM is just a machine component. The CPU is a machine component. So each of these hard drive. What are you calling a machine? Tower, server. Vertical scaling is easier and consistent of increasing single machine resources such as RAM and CPU. However, it has two major drawbacks. First, at some level, increasing a single machine's resources becomes disproportionately more expensive compared to splitting the load between several smaller machines. Second, the popular cloud hosting providers limit the size of the machine instances you can use, so scaling your application vertically can only be done up to a certain level. Horizontal scaling is more complicated and is done using several machines. Each machine will handle a part of the load, providing a better overall performance. The problem with horizontal database scaling is how to properly divide the data between different machines and how to manage the read-write operations between them. So I've got 20 field operatives all trying to update the same document. So that I've got 20 agents out in the field writing the Hitchhiker's Guide, and they're all trying to update the Wikipedia entry for Niagara Falls. Which one of those field agents' entry to the database takes priority? We all know it's Ford Prefect, but how do you tell the machine that? 24 minutes. Alright, we got just enough time. Let's finish this. Horizontal scaling is more complicated and is done using several machines. Each machine will handle a part of the load, providing a better overall performance. The problem with horizontal database scaling is how to properly divide the data between different machines and how to manage the read-write operations between them. Luckily, MongoDB supports horizontal scaling, which it refers to as sharding. Sharding is the process of splitting the data between different machines or shards. Each shard holds a portion of the data and functions as a separate database. The collection of several shards together is what forms a single logical database. Operations are performed through services called query routers, which ask the configuration servers how to delegate each operation to the right shard. To learn more about Mongo database sharding, visit manual sharding. So, MongoDB. At the beginning of 2015, the MongoDB team introduced the third major version of the MongoDB database. Above all else, this version marks the transition of MongoDB is making towards becoming a leading database solution for bigger and more complex production environments, or as the team describes it, making MongoDB the default database for every organization. In order to do so, the team presented several new features: storage API, enhanced query engine introspection, better authentication and auditing, better logging. These features and many others are what make MongoDB so popular. Although there are many good alternatives, MongoDB is becoming more and more ubiquitous among developers and is on its way to become one of the world's leading database solutions. Let's dive a little deeper to find out how you can easily start using MongoDB. Okay, we at 26. Let's review this. We finished the page, but let's review this. We just kind of skipped over it. In this version, the storage engine layer is decoupled from higher level operations. This means organization can now choose which storage engine to use according to their application needs, gaining up to 10 times better performance. Enhanced query engine introspection. This allows the database to better analyze key queries, making sure performance is optimized. This allows larger organization to manage their MongoDB instance more securely. More elaborate logging features allow developers to better track MongoDB operations. More elaborate logging features. Alright. This shell, we'll call that, it's 27 minutes. We'll call that the end of it for this episode. The little break here. Stop recording.